Where would we be in our technological society without the magic of portable power? I'm talking about batteries. Yeah, I'm talking about those things that make portable electronics possible. I mean, everything portable runs on a battery. I mean, I got a watch here. This watch runs on a battery. My phone runs on a battery. Even this electronic fly swatter runs on a battery. Portable power is very useful. Get out of here! So how exactly is it that a battery operates? It's very simple. Essentially, you've got yourself a container that's split into two sections. So one side of your battery undergoes oxidation. This is called the anode. The electrons that are lost with the oxidation come out of the negative end of the battery into a device to power it, and then into the positive end of the battery where they're gained by something inside the battery, and that's called the cathode. All batteries, or should I say voltaic cells, because a battery is really made up of multiple cells all just hooked together. For example, this is a 6-volt battery made of 4 1.5-volt voltaic cells. Why are they called voltaic cells? Because they produce volts, a unit of electromotive force, or the ability to force electrons to go from the anode to the cathode. The purpose of a voltaic cell is to use a spontaneous redox reaction to create electrical current. Why? So we can power portable devices. The two half reactions that make this go are carried out in two separate containers that are called half cells. The oxidation half cell contains a metal electrode, which we call the anode, or the negative electrode. And it's made of the more active of the two metals that you're using with a solution of the metal ion. For example, if the electrode is zinc, then the solution would be zinc nitrate. Now, this is a spectator ion. Why is it nitrate? Well, because nitrate is guaranteed to be water soluble. If you chose something like sulfate, sulfate's got some exceptions. You're always safest sticking with nitrate. If the electrode was magnesium, then a solution of magnesium nitrate would be in order. The other side of the cell, the reduction half cell, contains a metal electrode which we call the cathode, or the positive electrode, made of the less active of the two metals with a solution of the metal ion. Now once again, how do we know which metals are active and which are less active? It's down to reference table J. So if your two metals that you're going to use for your cell are calcium and magnesium, the calcium is the more active metal, the magnesium is the less active metal. If the metals we use are zinc and copper, the zinc is the more active metal and the copper is the less active metal. Therefore, zinc is going to be the anode, the copper will be the cathode, and the electrons will travel from the zinc side of the cell to the copper side of the cell. In the meantime, you can capture those electrons and use them to power a device. The two solutions are connected by a salt bridge, which is a semi-permeable membrane, which means it selectively lets certain things through and doesn't let other things through. It allows spectator ions to travel across. Now you can use any salt you want to make the salt bridge, but it cannot contain either electrode's metal ion. So if we're using zinc and copper as our electrodes, we can't use a zinc salt and we can't use a copper salt. But we could use any other element because it won't interfere with our reaction. The two metal electrodes are connected with a wire, and the device you're powering is called the load. The anode, the negative end of your cell, will lose electrons. Those electrons will get pulled through the load, which uses the electrical current. Then the electrons will be gained by the cathode. So electrons always go from anode to cathode. Always. So, to sum this up, if the two electrodes are made out of magnesium and zinc, because magnesium is the more active metal, it's going to be the anode. It will be what loses electrons. The zinc will be the metal that's used at the cathode. So electrons will flow through the wire from the magnesium to the zinc, through your device powering it. If the electrodes are silver and aluminum, aluminum being the more active metal will be the anode. Silver being the less active metal will act as the cathode. Electrons will flow from anode to cathode. So electrons always flow from the anode to the cathode, and while they're going from one to the other, they power an electric device called a load. And the load, or electric device, is designed for electrons to pass in only one direction through it. Now what you need to do is go to the next video in the series, because there you're going to see a battery being built before your very eyes. A battery will actually be constructed, and how it works is going to be explained to you. And I'll also be drawing a schematic on the video after that that explains the cell that we just made. 3 videos in this series. Watch all 3 and get the full impact.